Hey guys, welcome back. We're going to continue with the last couple of days of the factoring unit. Now, there is no new things as far as ways to factor that we have to figure out. We've gone through the ways to factor. We know that there's GCF sometimes. We know that there's factoring trinomial. And then that unique one that we call the factoring of difference of two perfect squares. And we've looked at a review sheet and a quiz that's broken that up into those three sections. Well, today, when it says, how do you factor completely? Well, I get that title from the directions that will be on your problems. And all that simply means is that we're going to have to factor more than once. So, what do I mean by that? Well, let's take a look at exactly what I mean. It's a little bit easier when you see an example. Okay, factoring completely problems are problems where you're going to see a polynomial that they ask you to factor, but you're going to not only be able to factor out a GCF, but you'll be able to factor out what's left after you factor out the GCF. Okay, so let's take a look. The directions of this would say factor completely. Those directions that will indicate to you right away there's definitely a GCF. And if I look at this polynomial, I look at all the terms, the GCF here is 2. So the first thing I'm going to do is pull out that 2. Then what I'll be left with is x squared plus 7x plus 10. That's what I got when I divided everything by 2 here after I pulled out the GCF. Okay, now when you factor completely, what that means is what's left here can be factored again. So we're going to factor a second time. Now when I look at this is one of the ones where we go, okay, multiplies to be 10, 1 and 10, 2 and 5. And combines to be 7 in the middle. Oh, that must be 2 and 5. So I factor that one again, and then when I'm done, now I've said that thing is factored completely because I've factored out a GCF first, then I got my other two factors by factoring out that polynomial that was there after factoring out the GCF. So think of it as factoring twice in one problem. That's what it means to factor completely. Nothing new, no different ways of factoring, just the idea that you have to factor twice. Okay, let me clear this off. We'll now do one, or I'll guide you through one more, and then a couple of unique ones, and then that'll be it for the video. It's really kind of quick. Okay, so here we go again. 3x squared plus 15x minus 42. If we want to do this with me together, why don't you pause right now and see if you can figure out what the GCF is. Okay, if you said the GCF was 3, you were right. Now we divide everything by 3 to find out what is in parentheses, and we're going to be left with x squared plus 5x minus 14. Okay, well, based on the fact that it said I have to factor completely, that's a given to me that this can factor again. So again, pause the video if you want to try and factor x squared plus 5x minus 14. Okay, you're looking for numbers that multiply to be 14, that can combine to be 5, and I think 2 and 7 will work as long as the 7 is positive and the 2 is negative. So there's going to be my factors, x plus 7 and x minus 2. I had some people comment before and they asked, can you put the x minus 2 first and the x plus 7 second? Yeah, that doesn't matter. Okay, as long as the signs are positive 7 and negative 2, it doesn't matter the order in which you put them. Okay, well, that's factoring completely. Now, can it take different forms? It certainly can. So let's combine it with one that does like the difference of two perfect squares. So these ones here both are ones where I factor out a GCF, but then what I'm left with is a difference of two perfect squares. So again, if you want to pause the video and try both of them on your own, feel free to do that. Or you can just watch and listen as I guide you through. The directions would say factor completely. I didn't put that here, but they would say that. So the GCF here is simply 5, and I'm left with x squared minus 16. Now, x squared minus 16 is the difference of two perfect squares, so x plus 4, x minus 4. And I don't forget that 5. Don't forget that, okay? It's still one of the factors. All right, and this next one, a little bit more to it. 3 is part of the GCF, but there's also an x they have in common, so 3x is the GCF. So divide this by 3x, I end up with x squared. When I divide this by 3x, I get minus 9. So that factors again into x plus 3 and x minus 3. It's a difference of two perfect squares. And I'm done. Okay, and there it is, factoring completely. The idea that you're going to have to factor more than once. Always a GCF and then factor again. All right, good luck practicing with your homework tonight.